Hi everyone, in this video I will show you how to utilize SQLite within Google Colab. SQLite is an open source C language library that implements a small self-contained SQL database engine. A complete SQL database with multiple tables, indices, triggers, and views is contained in a single disk file. With all features enabled, the library size can be less than 768 kilobytes, depending on the target platform and compiler optimization settings. Because SQLite is self-contained, it can be run on Google Colab. Other database management systems like MongoDB and Postgres operate using client-server architecture, which requires access to ports. However, Google Colab's environment is managed and restricts access to ports. Please note you can access the notebook on GitHub. This is linked in the description below. Let us get into the code. In this tutorial, we will review how to create a SQLite database, read in data into the database, and run queries on the database. First, I am going to use the wget command to download a dataset from the UC Irvine Machine Learning repository. This dataset contains data points on individual households' electric power consumption. I am going to check that the data has been downloaded within the content folder, and we can see that we have it here. I'm going to click on the three dots, and I am going to copy the path. Now I am going to use the bash command unzip to unzip our dataset. I am going to go back into the content folder, and I am going to get the path to our dataset, which is saved in a text file. Now I am going to use the bash command head to check out our dataset. We can see that we have columns in the first row and then data points in the following rows. We can also see that the data is split by semicolons rather than commas, which we will have to use as our delimiter split later in our notebook. Next, I am going to import all of the libraries that I will work with. This includes SQLite 3, Pandas, and CSV. The first way that we can work with SQLite is with Pandas. I am going to create a variable called raw data path, and this is going to be the path to our text file that contains our data. Now I am going to read the data into a Pandas data frame. I'm going to call on Pandas and read CSV. I am going to input the raw data path. I need to specify that the rows are separated by a semicolon. I will also set the low memory equal to false. This tells Pandas to read in all the data in one go rather than in chunking, and this allows Pandas to accurately infer data types for the columns. I am now going to take a look at the dimensions of the data, meaning I want to see the number of rows and columns. I'll use print formatting to do this. If we look at the output, we can see that our data has 9 columns and a little over 2 million rows within the dataset. I will run the head function to take a look at our columns and first few rows within the data frame. Now I will create a database using SQLite's connect function. What I'm going to do is create a variable called con1. I am going to call on connect, and I am going to create a database called household_power.db. If I check the content directory, we will see that we have our database object there. I will use the Pandas data frame to create a table for our newly created database. For our first parameter, I will name the table. I will call it household_power. Next, I need to connect our table. I am going to input the con1 variable, which is the SQLite connection object. I will set if exists equal to replace, and this will replace the table if it already exists. I will set the index equal to false, and finally, I want to set all the data types for my columns. For my first 2 columns, I will set them as text values. For the remaining columns, I will set them as real or floating point numbers. Pandas has a function called readSQL that will allow you to run SQL queries. First, I am going to create a variable called query, and this is going to be a string that contains the query. The following query will output metadata for our table. We will execute our SQL query using Pandas readSQL function. I first have to input the query, then I have to input the connection variable. I will print out the result, and I am going to run the cell. We have our output here. CID is the column ID, name is the name of the column, type is the data type of the column, Not null indicates if the column has a not null constraint, 1 if not null, and 0 if it allows nulls. DFLT value stands for default value, and PK indicates if the column is part of the primary key, 1 if it is part of the primary key, and 0 if it is not part of the primary key. The next query I am going to run is to retrieve the dimensions or the total rows and columns of our table. Printing our results, we can see we have just over 2 million rows and 9 columns. Using the following query, I am going to retrieve the average household's power consumption within the dataset. The metric is in kilowatts, so the average consumption is approximately 1.08 kilowatts. The final query I will run utilizing Pandas is to retrieve the number of null or missing values across the columns within the dataset. From the result, we can see the only column that has null values is the null sub-metering 3 column. Once you are done working with your table, it is best practice to close the connection to the database. Besides Pandas, we can also work with the SQLite database using a cursor object from the SQLite 3 module. Like we did earlier, I am going to create a new SQLite connection. I am also going to create a new database. This time I will call the database household power 2. We can check the content directory again to ensure that the database has been created, and we can see that it has. Now I can create my cursor object. Using our connection, I am going to create a cursor instance. Using the cursor, I am going to call on the execute function, which can execute SQL statements. I will create a SQL statement to create a table, and then once I'm done with that, I am going to call on the connection and commit to save the changes. Next, I am going to use the open function and the CSV module to read in our data to the SQL database. Using the CSV reader function, I need to input the path to my file and set the delimiter as a semicolon. While I am reading the text file, I want to skip the first row, which contains our column names. For the underlying data, I am going to use list comprehension to replace all the question marks with the none type so we can better identify null values. I am going to create a query which prepares a template for inserting the data into the household power table. Now I will call on the execute many function from our cursor. This will execute the insert command for each row in the data list. Finally, I will commit the changes to the table. Now I can run queries on our table. Like before, I am going to create a variable query that is going to contain the SQL query. I am going to use the cursor.execute to execute the query. Then finally, I am going to get the result by calling on cursor.fetchAll. I am going to iterate over all of the columns within the result using a for loop and print out all the column names. We can see that we were able to retrieve all the column names with our SQL query. For the next query, I am going to find the number of households where the global active power exceeds 5 kilowatts. This time I will use the fetch1 function instead of fetchAll since we are running a single query. From the output, we can see that there were 17,547 households that met this criteria. For the final query, I want to find the 5 times of the day with the highest total power usage across all days within the dataset. We have our output, and the peak power usage is late in the evenings. Now that I am done with the table, I am going to close the connection. Thanks everyone for watching. I hope that this video was helpful. In the notebook, I linked the documentation site for SQLite. If you found the video helpful, feel free to like and subscribe. You can also connect with me on LinkedIn, X, GitHub, Medium, and Odyssey. I also have a podcast called The Aspiring STEM Geek, which you can check out on YouTube, Spotify, Apple Podcasts, Audible, and iHeartRadio. Thanks again for watching and happy coding.